Let's compute sine of 2 theta, cosine of 2 theta, and tangent of theta using this information here. So let's start with part A. What is sine of 2 theta? The double angle formula says this is equal to 2 sine of theta times cosine of theta. So to compute this, I'll put information into this side of my equation. Now, I know sine of theta is equal to 14 over 15, so I can just put this value here. What I don't know is, well, what's cosine of theta? The goal is to figure out cosine of theta using what sine of theta is equal to. To do this, I'm going to set up a right triangle. And sine is defined as the opposite over the hypotenuse. If I call this angle theta, 14 is the opposite side and 15 is the hypotenuse. The only thing that I don't know is the side adjacent to the angle. Cosine of this angle theta is this side divided by this side. I think I'll use the Pythagorean theorem to figure this out. That is a squared plus b squared is equal to c squared, where 14 is equal to b and c is equal to 15. Plugging this information in, we get a squared plus 14 squared is equal to 15 squared. So a squared plus 196 is equal to 225. If I subtract 196 from both sides, I get 29. And by taking the positive square root, I get that a is equal to the square root of 29. So I can't simplify this any further because 29 does not contain any factors that are perfect squares. So that is the length of side A. It is the square root of 29. All right, let's try filling in what we know over here. All right, so sine of 2 theta, it's equal to 2 times sine of theta, which was given as 14 over 15. And what's cosine of theta? Now we have to be careful here. I use this triangle to help figure out the adjacent side and the hypotenuse. Cosine would be the square root of 29 over 15. This side divided by this side. But this triangle, I drew it with an acute angle. And technically, we are told that the angle theta lies in the second quadrant. All we have to do is just note that cosine of theta in the second quadrant is negative. Therefore, I'm going to put a negative here. I included this because it told me that theta was in the second quadrant, and that's where cosine is negative. The rest of this problem is just multiplying the numerators and the denominators and potentially canceling any common factors. I don't see any common factors between the numerators and the denominators. I know the whole answer is negative. If I multiply the numerators, I get 28 times the square root of 29, all divided by 225, and that is the answer for sine of 2 theta. All right, on to part B. I want to figure out what cosine of 2 theta is equal to. There are 3 different formulas for the double angle formula for cosine. It's equal to cosine squared theta minus sine squared theta. It's equal to 2 cosine squared theta minus 1. It's actually also equal to 1 minus 2 sine squared theta. It's all of those things. You can use any of them that you want. I would recommend choosing the one that might be the easiest. And I think it's this one here. My reasoning for this is, well, we were given what sine of theta is. It's 14 over 15. This is much simpler than the value for cosine. It doesn't have a square root in it. So I'll put 14 over 15 here and simplify this to get my answer. That is, cosine of 2 theta is equal to, well, it's 1 minus 2 times 14 over 15 squared. That is equal to 1 minus, okay, if we square 14 over 15, that's going to be 196 all over 225. So continuing. All right, so we're going to have a common denominator of 225 because I'm going to write 1 as 225 over 225. I guess I'll multiply the 2 other fractions together. When I do that, let's see, this is 225 and 392 for the numerator. So here, I just multiplied this into one fraction. rewrote one as 225 over 225, so I could subtract them. 225 minus 392 is negative 167. And then the question is, maybe this fraction could be reduced. So I'm just going to check to see if there's any common factors between the numerator and the denominator. And I don't see any. And because of this, this is the final answer for part B. Now, how do I figure out tangent of 2 theta? There's a couple of ways to do it. You could use the double angle formula for tangent, but also tangent is defined as the ratio of sine to cosine. We can actually just divide the two answers that we have here to get the answer for tangent of 2 theta. I'm going to do that on the next slide. Here we have the values for sine of 2 theta and cosine of 2 theta. If you want to know what tangent of 2 theta is equal to, well, by definition, it's sine of the angle 2 theta divided by cosine of the angle 2 theta. I'll take this fraction and divide it by this one. So I guess I'll write that out like this. That's negative 28 root 29 all over 225. This is divided by, okay, the second one's negative 2. That's negative 167 over 225. When you divide a negative number by a negative number, the two negatives cancel. So I'm just going to say, well, this cancels with that. Second, if you're dividing by a fraction, you can change it to multiplication provided that you take the reciprocal of the second fraction. So that is 28 root 29 all over 225 times 225 over 167. This. It turns out that we can cancel the 225s and we can multiply the numerators and the denominators, which we get 28 root 29 all divided by 167. Now, of course, we just want to make sure there's no common factors. And let me check that. Let's see, 28 over 167. Yep, I am seeing no common factors between them, and therefore, this is the answer for tangent of 2 theta.